welcome to yet another interesting video based on data mining. So in today's video, we'll be solving a problem based on a priori algorithm for data mining. So before we solve a problem, let's have a basic understanding about what is a priori algorithm and where it is used. So a priori algorithm is nothing but is a algorithm for frequent item set mining in data set for relational as well as transactional databases. Like for example, in market based analysis, it is mainly used. For example, if you have an Amazon marketplace and if you buy some kind of items, like for example, if you buy iPhone, and then it's like more probabilities that you also buy a case and also like a tempered glass. So it's like kind of a relationship is there, and there are many association rules, like you map it and you buy those kind of frequent items. And also you have your YouTube. So in YouTube, these kind of videos, if you see like on frequent item set and pattern matching a priori algorithm, so the relevant items which you can see can be seen by like kind of recommended for you and recommended to you kind of thing. So it's like the key tags which I actually put in my videos, those which relate to other videos of certain kinds from other users can also be seen in your right side pane. So it's all based on association rules and it's worked on the a priori algorithm. So let's have a understanding about how to solve the a priori algorithm in data mining. So stay tuned. So the problem goes in this way. So you have been given the minimum support in some percentage, that is 60%. It can be varying for different problems, and then you have been given the minimum confidence 80%. So it's like minimum confidence for the time being, you just have to ignore while solving the problem. That we'll see later when we do the kind of association rules. So you have been given this chart or the information table. So it's like I've mentioned, frequent item set mining and also for the association rules. So you have kind of transactional databases and transactional data. So for that you have certain kind of TIDs, that is TID 100, 200, 300 likewise, and you have some certain kind of items word. So it's like basically the items. So this letters or the alphabets, that is MONKEY, these are the items, and since it is represented inside a braces, it's called as the item set. So it's like one item set. In transaction 200 there is another item set, donkey, then make, Lucy, cookie, and all those kind of things. So this is how the data set or the data table is given. Then we have given this problem, like you have to use the a priori algorithm to find the frequent item set from this and also list down their association rules. Now from a basic analysis we can see that like some intuitions, applying some intuitions, we can see this OKE and OKE from all this data of different transactional databases. The OKE items or the item set is appearing more frequently, and so it's the frequent item set. But then to go in a constructive manner, in order to consider certain steps and kind of certain formulas and all, we solve it in 8 different steps. So there are 8 different approaches or 8 different steps to this to solve. So it's basically easy. There is nothing to worry about solving this problem. So we basically start with generating certain kind of table, item set and support count, and then after we just compare those item sets with the minimum support we have. So just I talked about minimum support or the support. So that support is basically so in step 1 you have to generate certain kind of clusters we generate in this. So generate C1 cluster with minimum support. So like for this you need the minimum support or the support. So how you can get that? So support is given by this, that is minimum support, that is in 60%. You have to convert it, that is 60 divided by 100 and multiplied by the number of items or the number of transaction IDs, TIDs which are there. So in this you have 1, 2, 3, 4 and 5. So you have 5 different tran IDs, and so it will be 60 into 5, so that will be 3. So we have the minimum support. So I'll write here, that is minimum support is 3. So this is the value, that is min support is equal to 3. And so all the items which are there in that particular table or data set, you have to prune or you have to drop down which are less than 3, and we have to consider items which are greater than or equal to 3. And so we first begin with the data set. So we have this table, so I will try to fit in this. So you basically have items or the item set, just write items, and you have the support or the min support, anything is fine. So first what we do is we write all the alphabets or all the terms or all the items without repetition from this table. So first what we have M, then we have O, N, K, E and Y. And so now we have to, so the first set is completed, and so we need the second one. So it's like donkey is there. So monkey is completed, then donkey. So you just need to add D to it. So it's like D, O, N, K, E, Y. So that gets completed. Next we have A. So that makes make. You have M, A, K and E. Then you have U and you have C, that is down. So it's like MUCY, that is MUCY, and then you have finally as I think it's I. Yeah, we have I, so it's like cookie. You have C, O, O, K, I and E. Yeah, so this is how the table goes. Now we'll count the occurrence of each of these items from our particular item set that we have from this kind of table. Yeah, so this place is a little narrow, so that's fine, but then we count M is occurring or M is coming in this item set how many number of times. That is where we will count the frequency of that particular item. So M once, then you have twice, thrice, so 3 times. So support of M is 3 in this. Then you have O 1, 2, 3 and 4. Then you have N 1, 2, 2. Likewise you have to fill this table. So I already have this table, so I will just fill it. And so it is 5, 4, 3 and the rest all is 1, 1, 1. You can just cross check it, this item set. So I already made it, so I just filled it. Now what you have to do, you have to just filter out, or you have to drop out all the values which are less than greater than or equal to 3. So it will be greater than or equal to 3. So this is the threshold. So what you have to do, whichever value that is equal to 3. So 3 is equal, so it's equal to 3. It's greater than 3. It's less than 3. So we'll drop it. This will consider, this will consider, this will consider, and all this will just drop. So this is like you can consider as the initial cluster with so many data points of so many items. Then we found out the outliers or the noise, then we try to remove it or eliminate it. Now what we do, we just transfer it to a temporary labeled disk item or cluster. So for that we have the step 2. So what we do in this, we compare minimum support with C2 with C1. So C1 is our cluster. So in this cluster we just put all these values which we have. After we cancel this, so you need not write this tick and cross. This is just for demonstrative purpose. And then we'll be left with this all, that is items, and then we have the support count. And so we will be just putting, that is M, then we have O, then we have K, E and Y, K, E and Y, and then that's it. So it will be, this will be our next, that is temporary. So we'll just label it as L1. So just a label given to that particular temporary cluster, and so we'll write it support alongside it. So it will be O, then that is 543, right? Yeah, 543. So this will be our final after step 2. This will be a temporary cluster or the C1, that is item set. Now what will we do in step 2? It will be irrelevant that we consider this set again. So what we'll do, we try to make a pair of 2 items. Pair will be like 2 items will be there. So what we'll do, we just try to conjugate, or we just try to relate it with other items so that we get the another data set. So it will be like we'll generating the step 3. So we'll have generation step. So generate C2, that is second cluster what we'll have. And then what we do, we just create this table. And so we have items here, and then we have the support count. And so what we'll do, it's very easy. So just you have to write MO, then MK, ME, MY. So it becomes MO, MK, ME and MY. So once this is done, then it's OK, OE and OY. We just create it one by one, OE and OY, yeah, and then KE, KY, KE, KY, and then finally we have EY. Now what we'll do, we just do the similar way like we have did in this. We just compare this with the frequency of this, like MO is occurring how many times? Once is there, yeah, it's one time. Then MK is there, 1, then 2, then 3 is there. Then ME is there, 1 and 2, yeah, 2 times. So likewise I have this table again, so I'll just fill these values. So it will be here 2, it will be 3, then it will be 3, and it will be 2, 4, 3, 2. So it will be 2, 4, 3 and 2. And so we do the same thing like here, we compare greater than or equal to 3, that is the minimum support, we just compare. So this goes off, this stays, this goes, this stays, this stays, this goes, this stays, this stays, and this goes. So we'll be left with these many items. So what I will do, now I will compare it, that is our step 4 will be L2. That is the new label or the temporary cluster which I have for frequent item set mining. And so comparing minimum support with C2. So we do the same thing here. So it will be L2 here, and in L2 we have this items. We draw this table, we have items here, and then we have the support count. Yeah, and so we'll just consider those items, that is we have MK, we have OK, OE, OK, OE, and then you have KE and KY, KE and KY. So we'll be left with these all, and so we write the support count. So MK is 3, OK is 3, OE is 3, and KE is 4, and KY is also 3. Yeah. So next what we do, we try to create one more cluster, that is C3, and so we'll be generating a item set of having 3 different items. So we'll just pair it again. So that's also very easy. So you need not worry how to make a 3 pair items. So that's also very easy. So when it will be a 3 pair item, or when, how can you identify? Or it's like, if you think it's time consuming, then it's not so. Like if you have MK and if you have OK, so if there is something common between them, then only it will be making a 3 item set, that is MKO. Likewise, if you see MK and OE, nothing is common in that. Whereas MK and KE, K is common in that. So it will be MKE. So likewise, we will be generating another set. So we have, that is step 3. We have, that is step 5 we have. So we'll generate pairs for C3 we have. So we have the C3, and we draw this table again with items and with support count. And so we just do in that way. So it will be MKO. Remember, you have to maintain it in an item set and not only just the items, because they are asking us to find the frequent item set. Next we have, that is MKE, like I have shown here. Then you have MKY. Then you have OKE. And finally you have OKY. And then again you have to compare this along with this, that is MKO is coming how many times. So MKO once, then you have, yeah, it will be 1. So MKE once and twice, yeah, 2. MKY is MKY, and yeah, 2 times. So it will be 3 and 2. So again what you do, you just compare it with greater than or equal to 3, and just will consider this. this, and finally this. So in the basic analysis, what we did, we just have an understanding or intuition regarding, like, we have OK as a frequent item, and this is the final cluster. And so what will we do is, we do the step 6, that is compare that is C3 with minimum support, and so we'll be left with items and support count. So our item list will be, so our final frequent item set will be OKE with support count of 3. So this will be our final frequent item set. Now you just did this part, that is frequent item set. You also need to lay out or list down the association rules. So that's also very easy, nothing complicated in this. So what we do is, we just take this particular item set, that is OKE, and we have this kind of minimum and confidence. Minimum confidence 80% and with minimum support. So we create, that is step 7 will be creating association rules with support and confidence. Yeah, so support and confidence, and that will be for item set, that is OKE. So what will we do? So it's very easy, so I'll write it here in this part. So what we create is, now we want the association rules for this particular frequent item set. So we'll consider a table having 4 different columns, that is we have association rule, which rule is there, then we have the support here, then we have the confidence, and finally confidence represented in percentage. Confidence in percentage. So we'll have this kind of 4 columns, and so we'll just fill this, it's very easy. So basically, in order to determine the association rule, we just have to, so it's a general formula, like if you have 3 different items in this item set, so the association rule goes with the probability that n factorial, so it will be 3 factorial, so it will be 6. So you will have 6 different items, that is association rules for that. And so to create it's very easy, like you have to write O and K gives E or implies key. So it's like, for example, let's take the case of iPhone, and case can also buy a tempered glass, or O into E gives K, like a tempered glass or a iPhone can also purchase a customer the case. And so you can write it in n number of possible ways, and so we'll write in this way, that is O and K gives E, and so this is one rule. Then we have O and E gives K, this is another rule. Or you can have K and E gives O, so this got completed. Now you have to just reverse it on the opposite manner, like E gives O and K, then like it's K gives O and E, and finally you have O gives K and E. So this is how we construct this association table. Now what we do is, we write the support. So support is 3 for all these things. It's very easy, like in the step 6 we have seen, it's 3 for all this. Now we have to determine the confidence. So confidence, like how to determine the confidence, of what value we have to put in that. So it's like confidence is just a integer or a floating point value, but then in order to determine that the confidence, the formula is given in this way, like you have confidence is equal to the support, that is this one, this column, divided by the number of patterns occurring. Number of occurrence of patterns. Patterns means this pattern, whichever is there on the left hand side of this particular association rule. So what we'll do, we just check for these all things from this, and we'll write it and the confidence. So it will be support divided by the number of occurrence of the patterns. So for the first case it will be 3 divided by OK. So you just have to consider O and K. So O and K comes in this OK, OK and OK. So it will be 3 divided by 3, and so it's 1. So it's like 3 divided by 3 gives you 1. Like O and E, O and E, O and E, and O and E. So it's like again 3 divided by 3, that's 1. So it's like 3 divided by 3 divided in all cases, support is 3. And so we just have to change. So K and E, K once, 2, 3 and 4. So it will be 4. So it's like in this I have 0.75, and this it's like 3 by 5 is there, and 0.6, and this is 3 by 4, that is 0.75. And you have to convert it into confidence. That's very easy. You just have to multiply these values with 100. So it's like 1 into 100, 100. This will be 100. 0.75 into 100 is 75 percentage. This is 75, and this is 60 percentage, and this is 75. So next what we have given is, that is a minimum confidence. Like minimum support we have 60 percentage. So we convert it into, that is the support count. So here what we do, just rule with this. That's like, this is used with frequent item set, and this is used with association rule. So with 80% we'll just prune all those values which fall below 80%. So it's like we'll rule this, this and this, and so we'll have these two, that is we have this association rule. So our final step in this is you have the rules comparing with minimum confidence, that is we have the 80% minimum confidence, and so we have this association rules with support, and we have this confidence and this column, that is in percentage. And so we'll create this table having only these two association rules, that is one which satisfies 100%. So it will be O and K gives you E, and O and E gives you K. Support is 3, and this is 100%. And so this is how you solve a frequent item set mining for a priori algorithm, and also you list down the association rules. And finally you have to write the statement for this. Like hence the final association rules we have, hence final association rules are, we have O and K gives E, and O and E gives K, and so it is used for market based analysis. Like I have said in the start of this video, like this kind of association rules are mainly used in like recommendation systems, in like customer buying frequent kind of items. Like if a customer is buying bread, then it's like he'll buy butter or jam or kind of milk kind of item. So it's like it's related. So you have this association rules inputted into that machines. So this is also used in machine learning. So algorithm also learns like this kind of associations are there, so it has to give the user this kind of relevant items. So well, that's us all about regarding solving a problem based on a priori algorithm in data mining. So hope you guys enjoyed it. If you got educated by watching this video, please do like, share, comment, and most importantly, don't forget to subscribe to my channel. Thank you very much for watching this video.